In this video, we're going to go over a mystery solutions example problem. This one's going to be very similar to the mystery solutions lab that you're going to do. A few differences to it though. I mean, we have different compounds, but the idea is the same. So what I would recommend is make sure you are writing this out on a piece of paper because it's going to be hard to follow if you just are watching the video. This is just one of those things that you're going to want to write it down. Pause the video when you need to make sure you're not moving too fast because this can get a little bit complicated. So what you're going to have in lab is a situation just like this. You're going to be given 3 known solutions, and with our 3 known solutions, they'll be labeled, and then our unknown solutions, these are our options, but they're going to be labeled A, B, C, so on and so forth, okay? So what I want to do is I want to kind of have a game plan going into the lab. We're going to be mixing our knowns with our unknowns, and we're going to see what we get. So the way I do that is I want to find out a fingerprint. So we're going to use our solubility rules. Most of these are pretty straightforward, so I'm going to flip back and forth to these. But what we're going to do is we're going to cross our known solutions with our unknown solutions. So right now, I'm going to write down my unknown solutions. And I've got ammonium chloride. I've got calcium nitrate. I've got silver acetate. I've got potassium iodide. I've got strontium chloride. And I've got sodium carbonate. Those are my unknown, and then I'm going to cross them with my known solutions. So again, I'm just looking at that first page and just writing down what is in the table. And hopefully you look at these, and when we cross them, you can understand that they are going to be double replacement reactions. So I'm going to cross ammonium chloride here, ammonium chloride with hydrogen chloride or hydrochloric acid, and you might need to write out a few of these as far as the double replacement reaction. So we're going to get ammonium chloride plus hydrogen chloride, and hopefully you recognize on this specific example the anions are the same, and so we're going to get no reaction. So I'm just going to write no reaction here, NR. And I'm going to keep moving through here. So if we cross now ammonium chloride with sodium hydroxide, I'm going to get sodium chloride, and I'm going to get ammonium hydroxide. Now, that would be the double replacement reaction. What we're kind of looking for with these are precipitates or gases. So if I look up at my solubility rules, it might take you a little bit to refresh your memory on how to do these, but sodium is in group 1A, so that's going to be soluble, which is aqueous. And then ammonium, anytime you see ammonium, that is also going to be aqueous. And if you remember, for a double replacement reaction, we need a solid, liquid, or gas to be formed, not 2 aqueous products. So here I'm just going to erase that, and that is no reaction. Okay, now on this next one, I'm going to do the double replacement reaction in my head. Essentially, I'm just taking my cation from one and the anion of the other and putting them together. We get HCl, and we get ammonium sulfate. And hopefully you say H is group 1A and ammonium is always soluble. So this is also going to be no reaction. So at first it might appear like, why are we even doing this? But the fingerprint for this unknown solution of ammonium chloride, which might be labeled, letter E potentially, is that it's going to be no reaction with any of our known solutions. Okay, so that is its fingerprint. We're going to start to see as we do more of these that we're going to get different fingerprints. So I'm going to go through and I'm going to write out the potential products, and I'd like you can pause the video and just write out the potential products. So here we get calcium chloride, and here we get hydrogen nitrate. And remember, I'm thinking back to my periodic table from regular chemistry, and I got calcium +2 and Cl -1. So when I crisscross them or cancel the charges, I'm going to get CaCl2. So go ahead, and I'm going to do the same thing. I'm going to get the potential products, and then we're going to go through and quickly figure out their states of matter so we can figure out their fingerprint. So we're going to get sodium nitrate, and we're going to get calcium hydroxide. We're going to get hydrogen nitrate and calcium sulfate. We're going to get silver chloride and hydrogen acetate. We're going to get sodium acetate. We're going to get silver hydroxide. We're going to get hydrogen acetate. We're going to get silver sulfate. We're going to get potassium chloride. We're going to get hydrogen iodide. We're going to get sodium iodide. We're going to get potassium hydroxide. We're going to get hydrogen iodide and potassium sulfate. And these guys, we're going to get strontium chloride, which hopefully you can see that this is going to be no reaction just because the anions are the same, but we'll write the potential products. And then we're going to get hydrogen chloride. We're going to get sodium chloride and strontium hydroxide. We're going to get hydrogen chloride and strontium sulfate. And then on the last one, we're going to get sodium chloride and hydrogen carbonate. We're going to get sodium hydroxide and sodium carbonate. Hopefully you see that this is going to be no reaction because our cations on this case are going to be the same. And then on the last one, we're going to get hydrogen carbonate, and we're going to get sodium sulfate. Okay, so I've gone through, and I haven't worried about states of matter just yet. I did for that first row. We did that. Now, I'm going to go through, and I'm going to really consider my solubility rules. So I'm looking at this. I don't have it on the screen because I can't show both at the same time, but I'm definitely using my solubility rules here. I know them, so I don't have to look at it too much, but you may have to look at it, and that is okay for right now. So calcium chloride. Well, in here we have chlorine, which is rule number 3. And if you're looking at rule number 3, it says all chlorides, bromides, and iodides are always soluble. So this is going to be aqueous. Hydrogen nitrate, anything with hydrogen. Hydrogen's group 1A, so that's going to be aqueous. Sodium is group 1A as well, so that's going to be aqueous. And then we get to our first one that maybe is going to give us a solid. So hydroxides are rule number 5. And hydroxides are always not soluble. That means solid. But if it's group 1A, that's going to be aqueous. Ammonium hydroxide is going to be aqueous. And then I remember this CBS, calcium, strontium, and barium are always going to be aqueous as well with hydroxide. So this is actually going to be aqueous as well. And then we get hydrogen nitrate, that is going to be aqueous. Group 1A is always aqueous. And then calcium sulfate, we're going to go to, I think it's rule 4 with sulfate. Sulfates are always going to be aqueous, except, and the way I remember this is bad lead, hungry cats. Don't ask me why that helps me remember it, but that's how I remember it. So calcium with sulfate is going to be actually a solid. Okay, so what we get here is we get no reaction, and then solid. So you can see that between ammonium chloride and calcium nitrate, I have a different fingerprint. With the first one, ammonium chloride, I have no reaction, no reaction, no reaction. On the second one, I have no reaction, but then I have a solid. And you might even write here, I tend to write just PPT, so not PowerPoint, but precipitate. So I would expect to see, if I mix those two, maybe like a white solid. It might just look cloudy, when they mix, but it would be a white solid, most likely that forms. Sometimes they're colored, but most likely they're going to be white. Okay, so let's look through the next ones. We have silver chloride. That one is going to be a solid, actually. Chlorides are always aqueous except for silver, lead, and mercury. And then here, this guy's going to be aqueous, so we're going to get a precipitate, PPT. Sodium is always going to give you something that's aqueous. And then silver hydroxide. Hydroxides are always solid. Silver is not one of the exceptions, so we are going to get a precipitate. And maybe I'll box these so I can make sure I can know where they are. And then we're going to get aqueous and then solid. This is going to be PPT. Sulfates are actually maybe silver sulfate. Maybe I did that wrong. Nope, silver is not an exception. So silver sulfate is actually going to be aqueous. I did that wrong. Normally silver things are solid, but that's aqueous. So this guy's no reaction. What I'd like you to do is pause the video, go ahead and figure out the states of matter for the rest of these, and then you can unpause it and check. Some of them might have the same fingerprint, and so if that happens, don't freak out about it. We'll talk about how we fix that. Okay, so this guy's going to be aqueous, group 1A, aqueous. This guy's no reaction. Aqueous, aqueous. This guy's no reaction. Aqueous, aqueous. This guy's no reaction. Strontium chloride, aqueous, aqueous, no reaction. Sodium chloride is aqueous. I've got to look at the strontium hydroxide. Hydroxides are normally solid. Strontium is one of the exceptions, actually, so that will be aqueous. This is no reaction. And then HCl is aqueous. Sulfate with strontium, let's see. That will be aqueous as well. Okay. So we get no reaction. And then our last one now, you may have to refresh your memory here. With one thing, and that is hydrogen carbonate. This is going to be kind of an exception. H2CO3, if it can form, it will. And you can call it aqueous. According to solubility rules, it is definitely aqueous. But it's going to break down and decompose into H2O and CO2. H2O is liquid, CO2 is gas at room temperature. So you might say, okay, what would I see in lab? And if you say liquid water, you're not wrong, but you're probably not going to be able to notice liquid water compared to something that's already clear and in solution. So what we're going to see here is we're going to see fizzing, okay, or bubbles, okay? So that is going to be a different sort of fingerprint than something here where we have a precipitate. Okay, so we get aqueous, we're going to get CO2 fizz here, that's going to be the same thing, and then we're going to get aqueous. So let's go ahead and see which ones have unique fingerprints, and I'm going to highlight them in yellow, that we're going to be able to tell them apart. They might not go in this order, like the first one we do might not be ammonium chloride, but we'll be able to tell its fingerprint. So I think if I look at this, we are not able to tell. We still need to figure out ammonium chloride because that one has no reaction across the board. We need to figure out potassium iodide. That one is the same. We need to figure out strontium chloride. And then I think the rest of them are different. So let's see how they're different. Calcium nitrate is no reaction, precipitate. Let me make sure I have nothing that goes in that order. I do not. So this guy is good. Silver acetate is precipitate, no reaction. I do not have any others that yield that same combination. So this guy is good. And then sodium carbonate is going to be the only one where I ran into H2CO3 to give me fizz. And so there, that's actually going to be a unique combination with fizz, no reaction, and then fizz. So I've got 3 of them, and that's pretty good if you cross them in the lab and you get about half of them. So now I'm going to move on, and I'm going to say, okay, ammonium chloride, potassium iodide, and strontium chloride. Those are now my unknowns. They were always unknowns, but they're still unknowns. And what you got to understand is I've already crossed everything with these guys. So these guys are sort of out of the picture. We might come back and use them in a couple instances if we really needed to, if something went weird, but I don't think we're really going to need them. What now is our known is we have calcium nitrate, we have silver acetate, and we have sodium carbonate. So those are now our known. And what I'm going to do is I'm going to try to look at my solubility rules, and I'm going to notice that we have chlorides and iodides, and those both follow rule number 3. Okay, and then we have ammonium and potassium. Those follow the same rules. So what I'm going to do is I'm going to think about, okay, strontium here follows kind of a different rule. There's no rule for strontium. And so is there any combination that we could do with strontium that might give us a precipitate? So if we did strontium with nitrate, all nitrates give us no precipitate. So that's not going to be different. If we did strontium with acetate, that's not going to be any different. Acetates don't give us precipitates. But if you scroll up and you look at rule number 6 on your solubility rules, we have carbonates. Carbonates tend to give us precipitates. They're not soluble. And strontium is not an exception. So what I'm going to do here, and we are frozen, so let's see if this gets, there we go, is I'm going to cross my unknowns. And remember, even though it seems obvious which one is which here, they won't be labeled. They'll be labeled maybe A, B, and C. So I'm going to cross my unknowns with sodium carbonate. We now know sodium carbonate. It might be letter D, for example. Here, we're going to get no reaction. Here, we're going to get no reaction. And then here, we're going to get strontium carbonate. And we're going to get sodium chloride. And we know that this is going to be a precipitate. And so that has given us an identifying factor for strontium chloride. Now what I'm going to do is I'm going to copy this. I'm going to move it down here, and we're going to figure out our last 2. This guy just moved over to this column because we now know it. And then we've got to figure out these 2. The problem is you're going to have to do this in lab, and you might have to use Google to help you out because you don't always know everything. Is we're going to cross ammonium chloride. We're going to cross potassium iodide with something. But the thing is, ammonium and potassium both have the same solubility rules. They're both always going to, they're not going to give you a precipitate. Chlorides and iodides, they also have the same solubility rules. They can give you some precipitates with silver, lead, and mercury, but if iodide gives you precipitate, so will chloride. Okay, so we're gonna be left with that we have to figure out a way to tell them apart. And so a great way to tell something apart is the color of the precipitate. So what I want to do is I want to look at my knowns now. And calcium with chlorine, not going to give us a precipitate, so that's not going to be helpful. Silver with chlorine will, or iodine, so that might be helpful. Sodium will not, and strontium will not. So we're going to have to cross this with silver acetate. And we're going to get silver chloride, and we're going to get silver iodide, both precipitates. So right now on paper, it might look like you can't really tell them apart, but if you use Google to look this up, you'll find that silver chloride is a white precipitate, and then silver iodide is actually a yellow precipitate. And so that color helps us tell them apart. Okay, so wrapping up this video, the thing is for your pre-lab, you need to do your pre-lab before you do the lab, and the pre-lab is the bulk of the work, okay? It's going to look exactly like this. It's going to be just different compounds, some of them different here, some of them different here. You are going to do your pre-lab where you just cross them. That way you kind of know the fingerprints that you're looking for. And then when you're in lab, instead of it being labeled ammonium chloride, calcium nitrate, silver acetate, what you're going to do is you're going to cross A, B, C, D, so on and so forth with your knowns. And then you're going to start mixing them, and you can start telling some of them apart. So then A might turn into ammonium chloride or something. Then on your pre-lab, you want to make sure that you're not just doing one giant problem like we did. You do need to do that, and then you probably need a couple other ways to figure out your remaining unknowns like we did. There's plenty of different ways that you can go about this, where you and your lab partner might come together on the day of the lab and have different ways you were going to go about getting that, and that might actually be helpful. That way you can ensure that you do the lab well. If you don't come in with the pre-lab done, you're not going to be able to get the lab done. It's just not going to be enough time, okay? If you get your pre-lab done and you've done it well, you're going to have more than enough time to make sure you get everything right and even get your post-lab done, okay? So you're really going to be saving yourself time and stress in the long run.